Major support for Do the Math has been provided by Chevron, Edison International, the Kern County Superintendent of Schools, Kern High School District, Panama Buena Vista Union School District, and Valley Strong Credit Union. With additional production assistance provided by these supporters of education in Kern County and throughout the state of California.
Well, good afternoon and welcome to Do the Math. I'm Michael.
I'm Cece.
I'm Starler. For math homework help, call in Bakersfield 636-4357. Everywhere else, 1-866-636-6284. Email dothemath@current.org. We're online at dothemathonline.net and on social media.
All right, thank you for that, Starlet. So where do you attend school?
Thompson Junior High.
And what grade are you in?
8th.
8th grade going pretty well so far?
Yeah, it's super fun.
Good. What is the best thing about 8th grade then if it's super fun? Because a lot of kids go, yeah, it's all right.
Well, we got really good teachers this year.
Oh, good. Well, that makes all the difference, right? Because then it makes it a little more enjoyable to go to class and you actually learn a little bit more when you're having an enjoyable time in class. Mm-hmm. Is there anything that you are looking forward to when you go to high school?
Honestly, not really.
Okay. Is there anything that you're going to miss from junior high school?
It's going to be sad that we have early outs on Mondays instead of Wednesdays.
Oh, so in high school you're going to have early out on Monday?
Mm-hmm.
All right, and you like it on Wednesday?
Yeah.
But you're still cool with an early out no matter when it is?
Yeah.
Yeah, I think I'd be all right with that too, right? Doesn't matter what day we have it, but if we get an early out. So do you do other things at school besides go to school? Any extracurricular activities during school, after school?
I do volleyball.
Okay. And have you done that for a number of years, or is this something new?
This is my first year.
This is your first year. And you like it so far?
Yeah, it's super fun.
All right, good. So do you set, do you dig, you spike, what do you do? Or do you do all of it?
Kind of like all of it.
Okay. And how's your team doing so far?
We're pretty cool.
All right, good. Well, I'm glad everything's going well for you. How's math class going?
It's fun.
Good. You ready to help me out with a problem?
Sure.
All right, let's take a look at today's social media problem of the day. So people get this on social media and then they submit their answers. So sometimes they get them all right. They're like, oh, that was an easy one. And sometimes they get a little tricky. So this one, as soon as you see this, what comes into your mind? Like, what are you thinking of as soon as you see this problem?
Honestly, I'm guessing C.
Okay, why are you guessing C?
It can't be 180 because 180 is a line, and it seems to be over 90 degrees, so it can't be 64. So it's either going to be 100 or 20 or 116.
Okay, and so that's some good reasoning right there why you think that, right? Because you know it's going to be an obtuse angle. It is bigger than 90 degrees. But 116 and 120 are pretty close.
Yeah.
But you're thinking 116.
Yeah.
All right. Do you know what complementary angles are?
Aren't those two angles that are like the same?
They add up to 90 degrees, right? So if we had one angle that was 30, and what would the other one be in order for them to be complementary?
60.
Right. Supplementary angles add up to 180. So these are neither one of those, but have you ever heard of corresponding angles?
I'm guessing it's two angles that add up to 360. I'm guessing.
It's a good guess.
I'm saying
Considering what he was talking about, I think that's a nice guess.
Right. And interior angles and alternate interior angles and stuff like that. Have you done that stuff in class yet?
Probably not.
Okay. Well, here's the best thing about this. When you are, I believe, in 10th grade, you're going to be doing all sorts of this stuff. And if right now you think that C is the correct answer based on your observations and kind of what you know about angles right now, you want to stick with C?
Sure.
Can I point out something just really quickly?
Yeah.
The reason that we have to really pay attention to those arrows to show that those are parallel lines, that's important.
Right. Yeah, because if they weren't parallel, then we would not be able to go, oh, we can look at it and go, that's 116.
Absolutely.
All right, so you ready to find out? All right, let's take a look. See if C is indeed the correct answer. There you go. First problem, all done. See how easy that was? All right. 636-4357 is that phone number. We do have phone tutors available most Tuesdays and Wednesdays throughout the regular school year. Time now for today's Math in the News. All right. Now, yesterday at the end of the program, we were talking about alligator lizards. And, you know, I just thought of this very second, and I don't know if you guys are old enough, but I know John will be. There was a band called America, all right? And I think they talked about maybe an alligator lizard in one of the songs.
How
I was just
funny.
thinking about that right now. But anyway, from COM, we have Elizabeth
Yes.
and Chris. How are you guys today?
Good.
Doing
How are
great.
you?
I'm doing excellent myself. So we do have an alligator lizard in here. So first of all, Chris, while you deal with the alligator lizard,
Oh, he's doing okay.
Elizabeth, what is your role with COM?
I am the Volunteer and Community Engagement Facilitator.
So if somebody wanted to volunteer for COM,
Yes.
they would get in touch with you.
Yes, they could. And all of the information is actually on our website at comzoo.org/volunteers.
And is there a time of year that you need more volunteers than others, or is it just all the time?
Yeah, all the time. We love having volunteers out there, as many as we can get. There's always projects to be done at ComZoo. We do have a couple of events that are going to be coming up where I will desperately need as many volunteers as I can get my hands on for our Boo at the Zoo event that will be actually next week, and then Holiday Lights that will be coming up in the end of November.
Right. So other than cleaning scat, what is maybe two of the other things that volunteers would be asked to do when they're out there?
Well, actually, I have a project set up for tomorrow for one of my volunteers to help clean out a freezer. So the random tasks like that, they help our animal keepers stay on track with what their duties are too. The cleanup volunteers help. We always have weeds to be pulled because we can't use pesticides near the exhibit. So they all have to be hand pulled, and that takes a lot of time. So those are really some fun activities. We
And
try to
you're-
make it nice.
And you're around the animals also.
You are. You
right.
get to have that experience.
Chris, your role with the COM Zoo.
At ComZoo, I am an animal keeper one, so pretty much I'm assigned to a group of animals and I do their daily care from cleaning their exhibits to giving them enrichment, things to play with, or medication as well.
So what group are you in charge of?
So my area is called the farm, which everybody knows the farm area. We got donkeys, ponies, sheep. We have the nice pig Tonks, one of my favorites. And then I also take care of a lot of waterfowl, pelicans, ducks, geese. I have heron and a little teal, which is kind of like a little duck. And then quite a few owls. I have long-eared owl and a great horned owl, and then a sulcata tortoise and western pond turtles.
That's quite the list.
He's got quite the list of animals he takes care
And
of.
it's worth it to see every one of them every
And I
day.
was going to say, because it's constantly evolving based on what animals are being released, if possible, and then what ones are coming in.
Yep, and typically they try to release as many as possible. It's not
I mean, that's the
ideal
goal.
to keep them.
That's the goal.
Right.
That's the goal.
So, an alligator lizard. So, explain to us a little bit about the alligator lizard.
Okay, so this is Alberto. He's one of our collection animals you can see in the reptile house. He is a southern alligator lizard. There are several species and subspecies of the alligator lizard. They go from Baja California all the way up to Washington State. And what's cool about them, they got their name alligator lizard because under their scales, they have bony plates on the back and the stomach, just like an alligator, which is not something that's typical for most lizards. If you see them up real close, you can see they have bumps going down their scales. It's called a keeled scale. And
How old is this?
So-
Do you know? I mean, because sometimes you get them and you're not.
so, yep, and that's exactly his case. Alberto came to us through the rehab. He was found in a potted plant from a lady that drove up from San Diego, and then she turned him into us here.
So
in
she
Bakersfield.
bought a potted plant.
It was given to her from her sister.
Oh, so maybe her sister wanted to be like, I could have just
Here's
got for you
Alyssa,
your
too.
potted plant here. So she found this and then knew where to go, brought it to you guys.
Yep, brought it to us, and we kept him for a while. He's got a really calm demeanor for alligator lizards. Typically, they're feisty, but Alberto, he just likes
So let's
to be
say
here
you
in the
had a
house.
feisty one on hand and you happen to bring him in here. Would he be like all on you, like going up on you and stuff right now, or trying to snap at you somehow, or
nope,
claw?
it's exactly that. So they open their mouth and they got a really strong bite. I actually got bit by by Alberto here once, just one time because he was in the rehab and we didn't really know much about him. He bit me and they have
A little scolding right at that time was going, you know, like,
and then now
that
we know
kinda
you just
shocking,
got to
right?
treat him nice.
Probably bit you on the hand or something, right?
Yep, right on the finger.
Yeah, okay. So how old do alligator lizards live to, typically?
So the most information shows that alligator lizards can live 5 to 10 years, and that's going to be in captivity or in the wild.
And how large can they? I mean, is he at
So
pretty much adult size now?
through what I've done research, the largest species, which I wouldn't be Alberto's species,
'Cause
gets
this
up
is
to
a southern,
16
right?
inches. Yep.
Okay.
This is a southern. So according to the cowherps, the southern alligator lizards, their eyes are a yellowish color, and then the northern alligator lizards have a darker colored eye.
So does he have the ability to jump and leap?
He actually can. Yep. So
Because I was wondering as he was getting closer down
he's
your
not-
arm, if
He's
he
about
was
to
going to
jump
go
on
from
you.
one person to the next there. So I was
not
just
quite
wondering,
as
okay.
much as like you see some of the other lizards, because you look at his body, his legs go out to the side instead of under him. So people more confuse these guys for a skink than they would think of them as like the fence lizards or blue belly lizards that people see around here.
Now, when he's in his display, is he able to be with other lizards, or is it just his own little pad?
So typically we would keep them alone. You could keep a male and female pair together, but we don't exactly know his sex, so it's best not to keep them together.
And what kind of diet does he have?
So he at the zoo is going to eat insects, and that's going to be typically what they're going to eat out in the wild too. A lot of insects and sometimes small eggs, but for Alberto, he gets a mixture of mealworms, dubia roaches, and crickets.
So he was brought to you in a potted plant by surprise by a lady that received it that way. So there wasn't really anything wrong with him at the time, was there? It was just she didn't know what to do with him.
Yes, yeah, no, she didn't know what to do with them, and he came to us, and if you just see, he doesn't have like a typical wild demeanor. He's really calm, so if he went back out into the wild, it would be assumed he wouldn't be able to hunt for himself, wouldn't be good at getting food.
Okay, well, that's going to be my next question was, is he even capable of being released based on what you've known so far?
So I was actually there when he came in, and I remember that was the decision that was made, was that he wouldn't be able to hunt for himself,
Okay.
and that's why we kept him there. And actually, when we moved him over to the collection side from the rehab, I remember holding him one day and noticing he had these little bugs, so he actually did have some mites on him when we brought him in. Went through a whole treatment, came back to the reptile house, and been in
And
there
that
ever
probably from the
since.
plant that he was in.
So yeah, so it's typical for lots of animals. They just live with those kind of things in the wild, because you got to imagine out in the big world, there's all these little creepy crawly parasites, tiny little bugs, ticks, mites, all that stuff. But out there, it's such a big open world, you can get away from them. But in a small enclosure, like in the reptile house or even your pet reptile, they can get overwhelming in numbers in there because there's nowhere for that lizard to get away from them.
Now, I don't know if the camera can pick this up, but kind of by his hind legs, we've got
Yep.
that little
so
raised
this is
area.
really interesting right now. When I brought him, he was not shedding, but due, I'm thinking, to the sweat in my hands and just
Okay.
the moisture, he is starting to shed. So his feet are shedding off, his back is shedding
Right, and
off
I can
now.
see
And we typically wouldn't
the
bring them
color
out like
also.
this, but this just kind of happened since we got here. So
Well,
you
this
guys
is
are gonna
awesome.
see
He's doing it live on TV.
Yeah.
Do the math.
Exactly. So that's a cool thing about alligator lizards, right? Is a lot of lizards, when they shed, it comes off in pieces. I know we had Rex, one of the other lizards I take care of on here. She sheds in pieces, but the alligator lizard can shed full body like a snake.
That's
Oh,
very
good.
cool.
Yep.
Yeah, well, I certainly do appreciate you guys coming out. A little bit more about Boo at the Zoo, when it
Yeah.
is and what people can expect.
It is going to be held next week, October 16th through the 20th. We are going to have the pumpkin patch out there for $5 pumpkins. Our train will be running $2 a rider, unlimited rides, and so you'll be able to do that all week long. We're promoting toddler days on Wednesday and Thursday, but anybody can come out at any time. It's going to be a lot of fun. We encourage everyone to get dressed up in their costume, and there'll be lots of games, and Hunsackers will be out there with his food truck, and it's just going to be a really great time.
Good. Well, I know the train rides are a lot of fun. I
They
know
are.
you're going to have conductor Steve out there. And,
Oh, I'm sure he'll be out there.
he'll be
Yep.
out there. But only $5 for a pumpkin.
Yeah.
That's
Pretty good
a nice
deal.
price for a
Pretty
pumpkin.
good
You
deal.
can go around
And you get
town
to,
and eat.
our animals will also get presentations. So every day we'll have 4 different presentations throughout the zoo. We love to do those pumpkin
All right.
presentations. So
Well, if you think of it, I think that song by America, maybe John helped me out, but I think that was Ventura Highway
okay.
that they referenced that. But anyway.
Good to know.
Elizabeth, Chris, thanks for coming in today.
Thank
See, you
you
learned
so
something, I learned
I
something.
did.
Right?
Thank you.
All right, that was today's Math in the News. We'll be back with more right after this.
All right, everybody, welcome on here. So today we're going to be looking at some of the different ways you can divide, especially when decimals are involved. A lot of times students will see decimals and think, oh my gosh, there's a dot on the page. It doesn't look like a regular number. How does that affect our answer? Well, let's take a look at a couple example problems here. Sometimes we'll see example problems such as 48 divided by 4. A lot of students might recognize this as a math fact and think, oh, it's 12, no problem at all. We can quickly do some mental math. 12 times 4 does make 48, so that checks out. But all of a sudden, if I do the same problem, but I add a dot in front of that 4, 48 divided by 0.4, all of a sudden becomes a mystery. Well, we don't need to let it scare us too much. If we look at these two problems, we notice we have a 4 that's in the ones place, but this 4 is not in the ones place. Because of that decimal placement, this is now in the tenths place. Well, the tenths place is vastly different than the ones place. We have a power of 10 difference. Well, if we think logically about it a little bit here, it would make sense that if I have 4 12s, I get 48. But if I put 12 down here, well, wait a minute. 12.4s, that's like saying 40 cents or 40% of something. I'm not going to get 48, so something has to be different here. Well, let's see. This one's a power of 10 smaller. Well, if it's smaller, I'm going to need more of it. Think about if you were to fill a box up with beach balls. You might not need as many, but if all of a sudden you're filling it up with sand, you're going to need a lot more of something. Well, luckily in math, it's not a guess. We know based on powers of 10, we can adjust. So if I have a power of 10 less, I need a power of 10 more of something to fill it up. So in this case, 48 divided by 4 tenths becomes 120. Let's check that out with another example here. If I have 72 divided by 24, if you think about hours in a day, 24 hours in a day, how many days to make 72? 3 days. Not a problem at all. But again, same concept. If I take these same numbers and set up a division problem, but instead of 24, now I have 2.4, 2 and 4 tenths. Again, looking at it, numerically, these are the exact same numbers. But in terms of the answer, I'm going to get two very different answers because I have a difference in a power of 10 in my problems here. 72 has remained the same, but 24 has now become 2 and 4 tenths. Again, we see a difference in a power of 10, so we have to account for that. Yes, we will have a 3 because they are the same numbers in the sense, but it's not the same value. So because 2.4 is a power of 10 less, remember I think of our beach balls filling up a box versus sand, we're going to need more of it because now this is a smaller value. Because of that power of 10 difference getting smaller, I need to get bigger. So again, when we powers of 10 getting larger to the right, we move that over, boom, we get 30. Now it makes more sense. 3 days at 24 hours gives me 72, but 3 at 2.4 will not become 72. Again, that power of 10 comes into play. Now we need 30 of them to account for that power of 10, but we do account for it in our answer. So there's a little quick math to help you out with decimals anytime in the future.
And thanks to Mickey for that and showing how those decimals do work in those problems. 636-4357 is the phone number. Phone tutors are available Tuesdays and Wednesdays. In studio with us, we have Starlet, an 8th grade student from Thompson Junior High, and super fun 8th grade so far this year. Mm-hmm. Are there any activities that you are know are going to be coming up this year that you're looking forward to at all?
Honor strings.
Okay. And is that, so that's something different. Is that the same as strolling strings or is that different?
It's different.
Okay.
So instead of memorizing music, you actually have the music in front of you, and there's actually chairs.
Okay. So that's a little bit easier when you're playing, right? Okay. So that's coming, when is that going to be happening?
Probably like in spring.
Okay. Well, I'm sure you're preparing for that right now, right?
Kind of.
All right. And what kind of things are you doing in class right now?
So in math, we're learning about slope.
All right, and I think you and Cece have got a problem over there, so why don't you guys go over there and take care of that problem.
Okay, so first off, I want to ask you, what is slope? What does that even mean? What are we talking about when I say, we're going to find slope?
It's like 2 points together-ish.
Okay, so for me, I always think about like a mountain, right? The slope of a mountain is really talking about what? Its steepness, how steep it is. So we're going to figure out how steep this line is. Can you show me how we're going to do that? So you're finding what right now?
The coordinates.
Okay, so we're trying to find the x and y value of that particular point right there. And it's got a y value of 1, an x value of 2. I like that. Okay. And then so my y value is, I like that. Okay, so for folks that don't know, how are we getting our x and y values? Just really briefly. Where do my x values come from?
This line.
Good. Okay, and where do my y values come from?
This
Fabulous.
line.
I love it. Okay, great. So we're going to find the slope. We're going to find the steepness of this line based on those 2 points. Show me. So while you work, go ahead. You can go ahead and do your thing, and I'll. So what are you doing right there?
I'm multiplying, I'm dividing the y and x.
Ah, you're right. We are going to put y's over x's. You're exactly right. But we're going to do the difference. This triangle means difference. The difference of our y's over the difference in our x's. So a lot of people may have heard it as rise over...
Slope. Rise over run.
Right, rise over run. Okay, so we're looking at the difference. So if I'm looking for the difference of my y's, how do I find the difference of my y's? Difference means?
Subtract.
Perfect. So what's the difference of my y's?
4.
Right, because, and I can always show it. I'm going to say 5 minus 1, okay, right, which you know is 4. Perfect, I love it. And then the difference in our x's. Okay, so I know that because I started with the 5, because I started with this y, I have to start with this x. So that first point here, and then I line up that second point there. So I like it. So my slope is?
2.
I like it. Good job. Fantastic. Okay, so we've got that. We doing another one, or we got to
No,
move
I
on?
think that's it for now.
Okay.
Right? So we got the basics out of that way. So that way, if some of the students are looking at it and just getting into it, a nice brief explanation on rise over run and how you get those values right there.
Perfect.
So nicely done. And for your great problem today, you've got yourself a certificate for any athletic event that you would like to go to at CSUB. So congratulations on that. I know volleyball, because you did say you were playing volleyball, right? So volleyball season is in full swing at CSUB. Basketball will be coming up, wrestling, baseball, swimming, soccer's going on, all sorts of sporting events. So hopefully you have an opportunity to go out to CSUB and see a sporting event of your choice. We'll be back with more right after this.
Where did our moon come from? Well, actually, there have been several theories over many decades. Earlier versions of lunar formation theories included capture, where the moon would have been a strayed planetoid. Another version was fission, where the Earth was spinning so fast that it would have warped out of the Earth and then formed its own body. This led to our current theory, the giant impactor theory. So this collision was during the late stages of planetary formation throughout our entire solar system, when planets were still very new and very much forming. So this happened when Earth was just an embryo, a baby planet. And this was actually in a crash course collision with Theia. which is a Mars-sized planetoid. And this collision ripped apart early Earth's crust, and that crust then coalesced, it snowballed into a whole separate entity, which we now call the moon. So, where did our moon come from? Well, currently, our understanding is that the Earth had collided with a Mars-sized object named Theia. But once we send future astronauts to the lunar surface again, who knows? We may actually have a whole new theory in the coming decades.
And for those of you that are not aware, we did a little bit on the second moon that we have right now for a couple of weeks. Not that you can see it with the visible eye, but we do have a second moon right now.
Crazy.
Well, crazier things have happened.
I
But
suppose. I don't know. That's a, you think constant, what's sort of set. I think the moon, we just have one.
right.
But we have
So I
two.
guess it is kind of crazy we have a second moon going on.
Little crazy.
All right. You ready to do some more crazy math?
Yeah.
I don't know if it's crazy math, but we're going to have Starlet go ahead and work on these problems. So Starlet, if you look over there, we have all of these different numbers, 3s, 4s, 5s, 6s, 7s, 8s, and 9s, but they all have to equal up to 6. In those boxes, you may put any operation symbols you like, add, subtract, multiply, divide. If you want to put parentheses any place, square root symbols, factorials, decimal points, anything at all, but you must always keep the 3 numbers and they must always equal 6. So how about you and Cece head over there and see how many of those you can get through in the next few moments.
How you feeling about this?
Nervous.
Yeah, I'm a little nervous too. I haven't done this. So we'll just decide where we want to start. Where would you, we don't have to start here. We can start somewhere else if you think that would be more fun.
Let's start with that.
You want to start with 3s? Okay, let's do it. Okay, so what are you thinking?
Wait, can you put like square?
Yeah. Yeah, you can square stuff. You can square root stuff. Mm-hmm.
So how about if I get you guys started off with one of them?
Okay.
That sound good? Since you're on the 3s, what were you thinking about doing first?
I was thinking of squaring -3.
Okay, and then?
Now you can't, okay, so
Wait.
you can't add any numbers.
Oh, you didn't tell
Only,
us that part.
well, see,
Okay, all
I said you can add, subtract, multiply, divide.
Okay.
Add things, but you can't add numbers. Adding an exponent is a number. So were you thinking about getting to 9?
So multiply?
Right, so why don't you go ahead and multiply the first 2, and then that should make it easy for the last one. What do you do with that now?
Subtract.
There you go, so 9 minus 3 equals 6. All right, good, that's first one done.
Okay, all right. Moving on to 4s. What are you thinking?
So I was thinking of like I was just thinking of multiplying it.
Okay. Because if we multiply, that gets us to 16, and then we'd have to do something with 4 to get down to 6.
Yeah, but it's gonna become like 8.
Okay, yeah, yep, I'm not sure about that one. So, okay, so what else can we do?
We can't divide the numbers and add by 4 either.
Right, because that would give us,
1.
yeah, that would give, yeah, well, if we divided here, that would give us 1, and then multiply there, that would end up with 4. So,
Now if you added
we-
them, so if you added the first 2, what could you do then?
if we add 4 plus 4, giving us
8.
Then
Is there anything you could do to that 4 to get a 2 out of it?
good
Divide.
point. That's very interesting. So if we have, okay, so he's saying if we add these,
Oh.
so if we add those, we get 8, right? What would we need to do in order to get to 6 from 8?
-2.
Minus 2. How do we get 2 from 4?
Divide it.
Okay, so we can't add a number, so we can't divide by anything to get it down to 2. But we can add symbols,
Oh.
so we can do subtract. What symbol can we add to this 4 in order to turn it into a 2?
Square.
Our square.
Root.
There we go. Yeah, so you can square root this 4. Okay, that'll work. Okay, I like that one. That's good. Okay, what do we want to do here? I have a theory on this one. This one I think I know. What do you want to do?
Divide the 5 and then into 1 and then add.
Okay, good. I like that. That works. What are we thinking here?
Minus a 6 and add 6.
That's good. That's good. Okay.
Right, some of them are
Yeah.
quick and easy, right?
Yeah, because I was going to divide to get down to 1 and then multiply. Because, yeah, anyway, but that definitely works. High five on that one. All right, good. What are we thinking here? So 7's in order to get to a 6. What's your first thought?
I was thinking dividing, but that's going to equal to 8.
Okay, so so if I went from 7 to go to 6, the easiest operation would be to do what?
Subtract.
Right. So we could start with 7, and then if we were going to subtract 1, how would we show 7 minus 1? So if this 7, and we're going to subtract, how do we do a 1 with those?
Parentheses.
We can do parentheses. I don't know that you have to, because order of operations would tell us we need to do division first anyway, right? So we know that, like you say, division would give us what number?
1.
Right, so we know if we did a division sign there, that would give us the 7 divided by 7 gives us 1. And then we'd have 7 minus 1.
Which would equal 6.
Which would equal 6. So go ahead and do a minus, and then division sign. And like you say, we could have added parentheses there just to show that that was what we wanted to do first, but don't forget, order of operations tells us I've got to do my division first, then I subtract. So this would automatically tell me I need to do that first. Okay, so 8s. I'm a little more skeptical about 8s, but maybe you got this.
Wait.
That would give me
2.
yeah, so order of operations would tell me I need to do this first. So that would give me 1, and I would have 8 plus 1 would give me
9.
9. Okay, so that's not going to work. So let's back off the bat maybe a little bit. What else can we do? So
Think about what you did with the 4s and use some square root symbols.
do 4. So if he's telling us to do a square root, if we were to add 8 plus 8, that would give me 16. I could take the square root of that, which would give me 4. But then I've still got another 8.
So think about another square root. So you can square root
Oh, what if we did...
once you already did it to that pair first.
Interesting. I think I'm missing what you're pitching me there.
So do the 8 plus 8 at the end.
So we're doing it here. So that's
Now
16.
square root that whole thing.
Okay, so we want to square root the 8 plus the 8?
Right.
Awesome.
And that now makes
4.
4. Right?
Okay, so
now we're going to put parentheses around that square root and the last 8. There you go. Now you're going to square root that again outside the parentheses. Don't put another
my
parentheses. Right
goodness.
outside that parentheses, the first one.
we're going to put a square root here.
So you're going to square root, no. Not before the 8, after the 8. There you go.
Oh my goodness gracious.
There you go.
Oh,
So now
goodness.
if you had 4 and you're square rooting that, what do you have?
Oh.
So the square root of 4 is...
Hold on. We're gonna mark this up just a little bit just so we can see what's happening. Okay. So we've got 8 plus 8, which is
16.
perfect. Okay, so we have 16, which has a square root and then a square root like this, right? What's the square root of 16?
4.
4. What's the square root of 4?
2.
2. So
Now you
this
have
whole
the 8
mess right
and a 2.
here is equal to 2. So we've got an 8 and we've got a 2.
Minus.
There you go. So now that we got that big old mess going on, who's going to square root a square root? That would have taken me all
That
day
just
to
makes
get
it a little
that.
more fun.
It is fun.
See, that's what we're here for.
We're fun. Okay,
All right,
there
get
we
that
go.
last one.
All right, let's do this. 9s. Hope it's not anything like that.
You're going to need a square root symbol again, too.
We're gonna need
Unless you think it's something
Oh, no,
else.
you're right. Okay, I can do that. I can go with that because 9s are great for square rooting because we get. What do we get if we take square roots of 9?
3.
So we know we can make every single one of these 3s. Since we can make every single one of those 3s. So if this is 3 plus 3, that's going to give me 6 minus 3. So that doesn't
3.
quite work. But you know what? Can I sort of cheat and then we'll find another way?
Go ahead.
Because we know we can change every single one of those to 3s. Look at what we can use.
Oh. That's smart.
So we can do that. So let's get this square root though over that 9. There we go. So square root of 9, 3, times square root of 9, 3. That gives me 9 minus 3. That gives me 6.
There you go. Nicely done. So see, you guys had to think a little bit, get a little creative right there.
Yeah, and then sort of, that's not cheating. It's using our tools.
Using resources that you have already done.
I like it. High
There you
five.
go.
Good job.
Great job right there. 636-4357 is that phone number. We'll be back with more right after this. Well, something we don't see an awful lot of here in Kern County, this part of California, is some hail. Have you ever lived where there's hail?
We get hail all the time. We got hail.
Stop it.
We got
Talking
hail
about we get
over the
hail in
summer.
Bakersfield?
Yes. Have you not noticed? We might not get snow.
John
We
waved
get
his hand
hail.
also at
We
you.
get hail all the
You don't even know what you're
time.
talking. You
Hey,
think-
New
you
Yorker,
think,
go
like,
back to
when
New York.
When the sprinklers are on and it's a little, you
Go
think
back
that's hail?
Go back and burn some
Stop
bologna in
it.
New York.
Hail. All right. So anyway, we'll move on from that. We have Starlet in studio. Starlet is an 8th grade student at Thompson. Now, Starlet, have you ever experienced hail?
Yep.
See?
She didn't say she was here in town. I just asked if she had experienced it. You like hail?
Yeah.
That's
And-
pretty
and
cool.
was
I mean,
it
unless
here
you
in
own
town?
something that's outside.
See, and it was here in town.
Great. I know that it has happened. I just said it's something that doesn't frequently happen.
Oh, okay, okay,
And I doubt when wintertime comes around, we will hardly see any hail at all.
okay.
Are you ready to do some more work?
Sure.
All right, girls, go ahead and work on that because I know you're working on slope in 8th grade.
Okay, so we're going to keep working on some slope problems. I'm going to change your color. Now, again, we talked about slope being that change, rise over run, or the change in what values over which values?
X over Wait, y over x.
Right, because it's our rise, which is our y values, over our runs, which are our x values there. Okay, so let's go ahead. I'm going to have you put some points on the board for us. So let's do positive 1, 1. And then can I throw a negative number at you?
Sure.
Okay, then let's do negative 5, 3. Negative 5, positive 3. Okay, so make sure we get all the way over to the negative 5 though.
Here?
So because we've got our x value is, oh, it doesn't want to, no. Oh, nope. You know, sometimes, there we go. It's because it's me. Okay, so we've got these 2 points. So 2 points make up or we can use 2 points to make a line, right, for the slope. And slope, of course, is how steep that line is. Okay, so do you want to label those, or what do you want to do, or how are you going to show me the slope on these?
I'll label them.
Okay.
First.
So negative 5, positive 3 was our, yeah. Okay, so go ahead and show me the way on this. So we've got our rise, which are our y values, excellent, over our x values. And it's always the difference of, so we're always subtracting. Good job, I like that. Okay. Okay, negative 2?
Over negative 6.
Well, negative 2?
Oh, wait.
You just put a negative positive.
Make it a positive. There you go. Okay, now show me what that is going to end up being. So we've got 2 over 6. Can we simplify that? Mm-hmm. Negative. Good. Okay, so this time we have a negative slope. The first one we had a positive 2, right? So this is a negative slope. How do I know what a negative slope should look like? How do I know that I'm right in having that negative number there? Do you know how to look at this to see whether or not we should have a negative or a positive?
So I'm not sure if this is correct. My teacher says that when a line goes that way, it's going to be positive, but when a line goes that way, it's going to be negative.
Absolutely. So we know that we always read graphs from left to right, just like we read a book. We read it from left to right. So if we're going from left to right and it's going down, we've got a negative slope. Yep. And so then if it's going up, and we can change, just draw me a positive sloped line. I love that. Yep. And we know that that's going to be a positive slope because reading it from left to right, we're going to go up. So that's perfect. That's how we can always kind of check to see if it should be negative or positive. Absolutely. Good.
Nicely done. So you've taken some of the work that you've done in class, applied it here with Cece, do a little negative work in there also at the same time. So nicely done. Hopefully that helps you out with the class a little bit also. We do have phone tutors available most Tuesdays and Wednesdays. Don't forget, as Elizabeth said, from COM, Boo at the Zoo is coming up, and that starts on October 16th. And that is from 9 to 4 each day. You can see that right there. So if you'd like to find out more or get your tickets, you can go to comzoo.org/events. And Starlet, have you thought about what you would like to do after high school?
Become a pharmacist.
Become a pharmacist. All right, good. Well, have you thought about any schools that are going to be able to head in that way?
Nope.
All right, well, you know what? We're going to check out one right now in the CSU system, Monterey Bay.
US. 2 letters that, when brought together, create one powerful idea. The sea otter knows. That's why, in the face of strong ocean currents, they join their bodies together, creating a living raft to protect the group. Because they know the simple, powerful truth that we know. That together, we are stronger. Cal State Monterey Bay is a mid-sized residential college that provides us with a strong otter raft, where we can explore the inspiring coastal environment within a supportive community that offers a personalized education and mentorship that empowers students to become compassionate leaders, ready to shape the future, where we become an otter for life.
At Cal State Monterey Bay, we are stronger when we embrace our differences and celebrate our diversity. When students have the freedom to be their authentic selves and find their people. When we are connected by a common spirit of creating positive change for the world. At Cal State Monterey Bay, we have the opportunity to thrive together because we live together. Our university has the most student housing of any CSU campus. So from residential halls to apartment-style living to homes in our East Campus neighborhoods, we forge bonds with each other that last a lifetime.
Our strength at Cal State Monterey Bay is offering a small faculty-to-student ratio that allowed us to get to know students in a more personal way. Like our $5 million USDA NIFA Next Gen grant that allows the students to conduct research, field work, and internships in agricultural planting soil science.
Those hands-on research and volunteer experiences set us apart from our peers when you graduate. From the estuaries of Monterey Bay to agricultural fields to local schools, museums, health clinics, nonprofits, or world-class resorts like Pebble Beach, we have the opportunity to get off campus and into the community where we put our knowledge into practice. As students here, we develop the skills we need to thrive in our chosen professions while learning to give back and pay it forward. We look forward to leaving Cal State Monterey Bay ready to be a driving force for global good, steering our lives and our community towards a brighter, more equitable future.
After finishing my associate's degree at Marine Church Colburn School of Nursing and working for a few years, Cal State Monterey Bay provided an affordable option to complete my Bachelor's of Science in Nursing. My strength is helping people heal and stay healthy in our community, and I have a passion for teaching the next generation of nurses.
I found my strength making others feel welcome and included, fostering sustainable practices in hospitality. Through the Sustainable Hospitality Management Program and internships at the Pebble Beach Company, I've gained real-world skills while making connections that will support me after I graduate from Cal State Monterey Bay.
Cal State Monterey Bay leads the CSU in its Graduation 2025 initiative. So we graduate on-time students prepared to realize the potential of an inspiring coastal environment and bring to life the knowledge gained from a community founded upon mentorship. Going beyond the expected to a place where individual aspirations are fueled by the greater good. To a place where connections are for life and where we truly believe in the strength of us. Cal State Monterey Bay is where I found my passion for school psychology. It's where I found best friends who also love to advocate for students. It's where I discovered my love of visiting local beaches. And it's where I am gaining an education that provides a lifetime of value.
We're all part of one other ref at Cal State Monterey Bay, and we're building a stronger future together. For us, for our university, for California and beyond.
That's why I'm an otter for life.
I'm an otter for life.
I'm an otter for life.
I am an otter for life.
I'm an otter for life.
The strength is in us.
See the strength in us.
The strength is in us.
Well, it is a beautiful campus and a beautiful area in that part of California, Cal State Monterey Bay. And you probably might have an opportunity to go visit some campuses when you get ready to go to school. And you're going to see some just beautiful places as you travel around. And I know that you did with your kids.
Yep,
and
absolutely.
One ended up at the University of Wisconsin.
That's right.
Never had the pleasure of going there, but I'm sure it's quite beautiful.
It's amazing.
Because how is it not going to be in Wisconsin,
Yeah,
right?
it's amazing.
And then a Trojan at USC.
That's right.
So
It's very
they're
exciting.
both doing well.
They are. They're thriving. It's very fun to see them move on to the next stage in life.
Good. Well, you know what? We're going to move you on to the next problem right now.
Fabulous.
So
Let's do
girls,
it.
head on over there. We had a phone caller phone in earlier and was doing a little bit of work on absolute value. And they weren't able to call back and do a problem with us. But we're going to do a little bit of absolute value so that way if that phone caller or other students find some help with this, Girls, take it away.
Okay, so we've got, these are called what?
Parentheses.
Okay, do you know what these are called? Starts with B, brackets.
Brackets.
And then we've got these. And what are those? It's okay, that's the one that most people don't remember. It's braces.
Oh.
And so they're all grouping symbols, right? They kind of group stuff together. Absolute value kind of groups stuff together too, but sometimes people get these confused and they're like, I think they're brackets. They're funny looking brackets or they're funny looking parentheses, but they're not. What's absolute value?
It's like the value of the number.
Okay, so we're talking about a number line, right? So we're talking about our number line, 1, 2, 3, say that we go all the way to 4. We go backwards this way to -4. So if I say, what's the absolute value of 4? You're going to tell me what?
4.
It's 4. Okay, fine. What if I asked you, what's the absolute value of -4?
It's still going to be 4.
Okay, so what does absolute value tell us?
It tells us how much distance the 4 is from the 0.
Ah, you're fantastic. I love you. That is like such a great definition. It is our distance from 0. So we know that we are going a distance of 0 to 4. We know we go a distance of 4 to -4. Distance is always
positive.
Fantastic. I love that. Okay, so if we're talking about this, let's go ahead and do something like say, and you can grab your pen and I'll change your color for you, but I'm going to do something, say like -5 plus 1 inside our absolute value. And what are we going to get? -5 plus 1.
Oh.
So you're right. So this right here, of course, gave us -4. Now let's not lose our absolute value quite yet. So now that we have that as negative, the absolute value of -4, what's our answer?
4.
4. So we know that this is equal to 4.
So Cece, as you're doing that, and you might do another one or two, but for students watching this for the very first time, absolute value, the answer will always be
positive.
That's the key right there,
Right.
because they'll go, oh yeah, I see how she got -4. Why isn't the answer -4?
Right.
But with absolute value, the answer will always be
Right,
positive.
because we're always talking about the
positive. Wait, distance.
Because we're always talking about a distance, and distance is always
positive.
You're so great. I love you. Okay. All right, so moving on, let's go ahead and do something a little different. We'll change up our colors again. I'm going to give you a couple more. Let's do a -5 times a -4 inside our absolute value, and take it away. You look concerned. Why are you looking concerned?
Wait, so doesn't a negative number times a negative number equal a positive
You're
number?
exactly right. You're fabulous.
So that's the answer?
So yeah, you're right, because really what we're saying is okay, first we're going to do this, and we're going to get that, and the absolute value of 20 is
20.
Now you know how many times people will say, well, it just changes the sign, right? It doesn't, because like we just talked about, it's always positive because it's always
distant.
Fantastic. Okay, I'm gonna
One more, and then I've got something else for you.
Okay, all right, okay. Because I was gonna say I've got something else, but let's go ahead. We'll humor him. We'll do this.
You see, with the will humor him, you know you've got something else coming up. I'll give you one more absolute value.
I got you. Okay.
All right.
Okay, so be careful. We don't want to do this quite yet. We're going to say this goes to here, which then equals
2.
That's it. Love it. I love it. Because once we've dealt with that absolute value, we're done. Can I do just one more thing really super fast?
Sure, we'll humor you. And
Okay,
you can do one
thank
more thing.
you. Thank you. Okay, can you do this for me? So my answer can be negative. It just can't be negative for my absolute value, right? Okay, good. Just making sure we're good with that, that we know that we can get a negative number as long as it's done after that absolute value.
You feeling better now?
I'm feeling so much better.
Calm?
Yes.
Clear the board.
Okay. Uh-oh, that means something crazy's coming. Here we go.
All right, scientific notation.
Oh, okay.
So Starlet, what do you know about scientific notation? Let Cece know, and then you guys kind of work on it a little bit, and you can show some students that have never experienced it, kind of how it works.
So it's basically a super, super big number that's simplified.
Okay, so you want to write up the really big number and then show me how to simplify it. That's a pretty big number. You want to make it bigger?
No, I'm good.
Okay, all right. So show me how I'm going to simplify that.
You place a decimal point, and then you just count how many zeros there are, or numbers after the decimal point.
Okay. So how am I going to write that? Nice. That's nicely done. I like that. I'm going to give you another one. You ready?
Sure.
And then you're going to tell me what we do with that? Okay. So I'm going to give you... Oh, no, I lied. I don't want that one. I wanted a comma there. Okay. Take it away. Why do you keep putting a decimal point right there?
Because so the number can't be higher than 10, so it could either equal 1 or be, so it can't be under 1.
Okay.
So it could equal or be a number before, over, but except it can't be higher than 10.
Okay, so fabulous. So we know our decimal point always has to exist behind that first number, right? Mm-hmm. Okay, good. And what are you counting all the zeros for?
So we could put, so we could get the 10, but like, when you put 10 as a with squared, it would become all those numbers.
You know, you're right. So if I have 10 to the first power, that equals?
10.
Yeah. And if I have 10 squared, that gives me?
100.
Good. So we're adding, this shows us how many zeros, but these aren't zeros. So why are we counting those? Aren't we supposed to just count zeros?
But they're after the 2.
Oh, they're at the decimal point. So we're really saying there was a decimal point here. We've shifted it all the way up to here, so we need to know how many place values we've gone, right? Okay, so show me how I'm going to write this. Okay, I'm gonna change just one thing about that. You put down 2, but that says that these don't matter.
Oh, wait.
Good, because they certainly do. We don't want them to feel bad about themselves. They matter. So you're right.
You have your 2.365.
Exactly.
There you go. Nicely done. So come on over here, girls. That was some excellent work so far today. So, Starlet, you are our newest ambassador for Do the Math. You know what that means?
No.
You have to simply let people know about Do the Math. You think you can do that?
What did I tell them about?
You can just tell them about the show, how there's a show available if you need some help, and how you were on it. Now you're going to be world famous and stuff like that. Sound good?
Okay.
All right, good. You ever seen one of these?
Yep.
Are you pretty good at them?
Nope.
Neither am I. But this is the exclusive Do the Math Rubik's Cube. And this is an exclusive. You're not going to find anybody else at Thompson Junior High that has one of these.
Okay.
All right. So that's one of your many gifts. So there are a few things that I want to find out. First of all, did you learn a little bit of something today?
Mm-hmm.
All right. Did you like the alligator lizard?
Yeah.
Don't forget the alligator lizard and a lot of other activities going to be going on at the Boo at the Zoo that starts up on October 16th. Did you have fun today?
Yeah.
That's the most important thing right there. And until we meet again, continue to do the math.
Major support for Do the Math has been provided by Chevron, Edison International, the Kern County Superintendent of Schools, Kern High School District, Panama Buena Vista Union School District, and Valley Strong Credit Union, with additional production assistance provided by these supporters of education in Kern County and throughout the state of California.